Thank you all for being here. Next, I have Donna Gilmore, followed by Jim Heddle.
Okay, yeah. Jim Heddle and Mary Beth Brannigan gave me their minutes.
Okay, yes. Okay. I also have her. So
okay.
You have up to 9 minutes.
Yes, okay, thank you. I'm going to be speaking about the dry cask storage situation in California and some important information that the Commission needs to know. There was a game changer that happened last year. The NRC finally said, well, I guess it's okay just to leave all this nuclear waste sitting right along our coastline, basically indefinitely. So we have Diablo Canyon, San Onofre, Humboldt Bay. So we're stuck with, you had approved what was a short-term decision to let them leave the waste there, and now we're faced with this being indefinitely. The problem is these canisters, based on research that I and others have done, these canisters that they're using may fail within 20 to 30 years from cracking from our corrosive marine environment. They cannot be inspected, they cannot be repaired, and they found at Diablo Canyon that they have canisters that were loaded with fuel for only 2 years that have all the conditions for cracking already. And they have no plan in place if one of these fails how to deal with it. Next slide. Now, San Onofre is proposing to put an underground system in. This is an experimental system. It's never been used anywhere in the world. They will tell you it's similar to one in Humboldt, but it's very different. I'm not going to go over all the details because I don't want to run out of time, but I've made these so you can look at them later without having me talk and still understand them. Let's go to the next one. Okay, so we covered the Diablo Canyon. There's more details on that. Let's go to the next one. And we said no spec. Oh, let's just go to the next one. Okay. There is a component at the Coburg nuclear plant in South Africa that has the same environment as our San Onofre situation with onshore winds, high moisture, and fog. The canister in Coburg failed in 17 years. It was thicker than our canisters. Our canisters in California are 1/2 to 5/8 inches thick, okay, 0.065 or 0.50. The Coburg canister, it was a storage tank that failed, was 0.6 inches deep. So 17 years before it failed, okay? Go to the next slide. So based on the loading time of the canisters in the United States, let's be optimistic and say we have at least 20 years before they crack all the way through. That means Rancho Seco, we could have a through-wall leak in 6 years. San Onofre, which is a much more corrosive environment, 8 years, and there's Humboldt and Diablo. So because I live about 5 miles from San Onofre, I'm focused on that one, and it's the most likely to go first, okay? So we have 8 years to deal with this problem. And go to the next slide. Okay. Just to let you know that I'm not making this stuff up, okay. I met with Dr. Chris Singh. He made a presentation at an Edison meeting. He says it's not practical to repair these canisters. This is the manufacturer that makes these things, the Diablo. And let's be realistic. You have to find the crack, and then it means to repair it. And you will have, in the face of millions of curies of radioactivity coming out of the canister, we think that's not a path forward. So we have him on tape. I've got a YouTube video of him speaking at an Edison presentation. And they have no plan to deal with the cracked canisters. They're going to allow them to destroy the spent fuel pools, which is the only way to recover from a failed canister. I'm dealing with the CPUC on the funding issue to try and stop Edison from buying the underground system and to stop from destroying the pools, but we could use Coastal Commission help. Transporting crack canisters to get them out of here, you don't want to transport cracking canisters. And there's no rating for crack canisters for a seismic event. Go to the next slide. Okay, so we didn't know, and they aren't even monitoring them for radiation. We will only know after they leak radiation. We will not know before. They have no early warning system in these things. Let's just go to the next one. So I never like to come with a problem without a solution. I find that's the most effective way to do things, and I'm sure you appreciate solutions and not just problems, all right? So after speaking with experts, engineers, nuclear physicists, scouring the world, doing my own homework, reading technical reports, the technology used in the rest of the world is thick canisters up to 20 inches thick. And we're using roughly half-inch thick canisters. And in comparing the two technologies, the thick ones don't crack, they can be repaired. They have seals, and Edison will tell you, oh, well, the seals might fail. Well, you have early warning, and if a seal fails, you can replace a seal. But if a canister cracks, you can't fix it. So, you know, ASME certification, this is American mechanical standards. We don't even have that certification for what we use. There's no defense in depth. They store theirs in concrete buildings for extra environmental and, you know, reinforcement from other external events. With these thin canisters, you have to use this 6 concrete overpack that has vent holes in it. So it gives the illusion you have this big, thick, heavy storage thing, but it's really vented so the thin canister can cool. So it isn't really providing any protection. The thick ones are the world leader. Okay, what Edison will tell you is the thick canisters are not licensed in the US. Here's the situation. It costs millions of dollars to apply for an NRC license, and it takes about 18 months. No vendor will apply for a license for their product unless they have a customer. And right now, there's no customer. So Edison has to be persuaded to at least get a bid from these thick canisters and evaluate that technology against what they're buying. So once there's a customer, then it'll take about 18 to 30 months max to get a license. And it's pretty much a rubber stamp with the NRC once you apply, so it's not like that wouldn't happen. So, and the fuel has to cool quite a few years in the pool, so there's not an issue of the concern about expediting it out of the pool. The fuel has to cool years longer. So there's time right now to do this. Go to the next one. All right, here's what the NRC is doing for us. They're approving canisters and ignoring anything that might go wrong after 20 years. I have the actual approval where they say, well, we're going to pretend that whatever happens after 20 years doesn't apply, so we're only saying this is good for 20 years. That's the current process at the NRC. And they're lowering their standards in order to continue to approve these thin canisters. Let's just skip it because I don't want to run out of time. Okay. This is how Germany stores their canisters. They put them in buildings. They have remote monitoring for all kinds of potential leaking conditions. It's clean. It's kept away from the marine environment. Let's go to the next one. Okay. And in terms of jurisdiction, I think under regulation code section 30253 that you have jurisdiction to deal with this. So when Edison comes in for their request to put in that underground system about 100 feet from the bluff, I think you have some jurisdiction to do something with this. Let's keep going. This is the amount of cesium-137 just at San Onofre, okay? And it's in comparison to, on the left is a 10 megaton weapon, that's how much cesium. The Chernobyl accident, all the atmospheric nuclear tests that have ever been done is that third one in the green. The other 3 is all San Onofre cesium, okay? So a problem here, I think use of the coast will be pretty much wiped out if we don't deal with this, okay? And the reason I'm here and doing this is because I've learned that I can't trust Edison. This is a chart showing they have the worst safety record in the nation. These are complaints from employees. The top bar is San Onofre. The other bars are all the other plants in the whole country, and they have the worst safety complaint record from employees.
Thank you.
Okay.
Your time is up, and appreciate it. Thank you very much. And that will complete our public comment for today. Happy to have been able to accommodate everyone who submitted a card. And so we will move on now to our North Coast District and the administrative calendar.
Thank you. Just one comment on that, if I might. The application for the dry cask storage at San Onofre has been submitted, and we're reviewing that right now.
Thank you.
So today I have a number of items for you. First, you received in your packet 4 de minimis waivers and 1 immaterial amendment. However, after receiving some very recent public comments and additional information, we decided to pull and not request your support for one of the waivers, Southern California Edison's proposal to install an independent cooling system to serve the existing spent fuel pools at Songs. Instead, I've advised the applicant to submit a CDP application. Your staff will more fully evaluate the safety and other concerns raised by members of the public and schedule this matter at a future hearing. And so just to be clear, we've pulled the de minimis waiver that's numbered 9-15-0162-W. And so regarding the rest of the waivers and the 1 immaterial amendment, we are asking you to concur today in the executive director's determination to grant these approvals.
Thank you. I do have some public comment on this. And I'd like to invite up David Asti, followed by Ron Pontes. Welcome.
Good morning, Commissioners. I believe Mr. Pontes has ceded his time to me, but I don't believe I'll need that much time.
Okay. Please.
First off, I'd like to just kind of set a general context that SCE has a very good working relationship with the Coastal Commission staff. We work very hard and very diligent to meet the staff's requests and keep them fully informed of all the projects that we have ongoing. As a result of that, I have to say that we are very disappointed with the decision to delay the Spent Fuel Island project 162-W. As you all know, SCE must undertake certain preliminary projects to enable the San Onofre Nuclear Generating Station, or SONGS, to proceed with the decommissioning process. The proposed Spent Fuel Island system facilitates plant decommissioning because it's smaller, simpler, it's more localized to the spent fuel areas than the existing once-through cooling system. It also replaces the OTC system, or once-through cooled system, eliminates the adverse impacts to marine organisms from impingement, entrainment, and the thermal discharge of cooling water to the ocean, as required by the State Water Board's once-through cooling policy, which was promulgated back on October 1st, 2010. This project, like the others, will be completed under SONG's existing NRC operating license in full compliance with the NRC regulations. And SCE has taken extensive measures to brief regulatory agencies. The Public Utilities Commission has been briefed on this project, State Lands Commission has been briefed on this project, and the Coastal Commission staff was fully briefed and consulted on this project before we ever filed the paperwork. SCE has invited public comment on all aspects of the decommissioning process, including this project, during the quarterly SONGS Community Engagement Panel meetings. Most recent one was held on April 16th in San Juan Capistrano. The project was deemed applicable for a de minimis waiver by staff in preparation originally for the March 11th through 13th meeting in Chula Vista down in San Diego. Again, it was on the consent agenda for the meeting in San Rafael. So it's been postponed twice until today, and now it's been postponed yet a third time. SCE has responded in detail to all questions that have been posed by the public. We agreed with the previous pulling of the de minimis waiver to address some of the questions that the public brought forward. We feel like we fully addressed those, and the staff has notified us that they are comfortable with the information we've submitted. And so the Commission staff, based on a thorough review, has again recommended the project be granted a de minimis waiver. Again, we are extremely disappointed that it's been pulled yet a third time. Currently, we're evaluating our options, but candidly, there is no reason for allowing a small segment of the population to derail this process. It's really a disservice to the public at this point. And that's the end of my comments. I'd like to thank you again for allowing me to speak on this particular issue.
Thank you.
Thank you so much.
I'm going to invite up Donna Gilmore, followed by Jim Heddle. Actually, these are ceding their time to Donna. Before that, I just wanted to be clear for the record that Commissioner Uranga recused himself because he had received a contribution within the period of time in excess of $250, and it's a requirement that we announce the purpose of the recusal. And so I had neglected to let him know that he was supposed to report that, but he will be back for the next item. Thank you. Ms. Gilmore.
Thank you. Yes, I've been following this issue very closely, and unfortunately, Edison has not been forthcoming with the information that the Coastal Commission needed to make a good decision. For example, Edison said, oh, they're making this spent fuel pool island. And I said, well, where has this been used before? I haven't heard of this technology. Oh, well, a lot of places have spent fuel islands. And then I ask a question most people don't ask. Well, what kind of technology do those places use? Do they use chillers like you're proposing? And I have been going back and forth over a month, 2 months, trying to get a straight answer out of Tom Palmisano, who's running the whole project. And up until yesterday, I did not have, he still didn't have an answer, and I had other people besides me, like Dave Lockbaum and other people. And then the staff, Coastal Commission staff has had to waste a lot of time on verifying Edison's information, and they have misled all of us. This is the first time this chiller technology has ever been used for cooling spent fuel pools. And the NRC doesn't plan to even look at this until after it's already installed, and then they'll come and take a look at it. So their rubber stamp is they're consistently rubber stamping. So it's because of Edison's lack of sharing information and not I have to work with Edison so much locally that I've learned how to read between the lines when they say things. And I have all the questions they answered, I submitted additional comments where they have misled the Coastal Commission once again with their information. So I can share this with the Commission, but it's really Edison not being forthcoming. I've attended every one of those public meetings that Edison talked about, and they were very vague. They just called it an island, not getting details. It's like pulling teeth to get anything out of them. So I think Edison has themselves to thank for this being such a debacle. Thank you.
Thank you. So remind me again then, do we have an item that we need to take a concurrence with, or you were just reporting on that, I believe?
That's correct. I think you took your action you needed to take.
All right. Thank you. So are you going to move on then?
Yeah, I do have more items, and I think the commissioners that left the room could come back now.
Thank you.
Pardon me?
Calling all Commissioner Urangos.
Oh, you didn't concur on the other, I'm sorry.
So
you
we
do
need
to
concur. Yes.
The other 3 de minimis waivers and the 1 immaterial amendment, we're seeking your concurrence. I'm sorry.
With that, is there any unwillingness for unanimous concurrence? Seeing none, we do concur.
Thank you.
What part of Fukushima do you not understand? When nuclear contamination hits the fan, plutonium is everywhere. It's in the sea, it's in the air, and we don't even have any evacuation plan. Google Fukushima, take a stand.
So the 2 major items: shut Diablo Canyon and bring Solartopia to Los Angeles. And we have now some great experts. As I say, I'll talk afterwards. And now we're going to proceed with Donna Gilmore. Donna is one of the great activists, very responsible for helping to shut San Onofre, and she is now in the process of raising the very serious issues about the decommissioning at San Onofre, about which many of you can actually go out and do things as we also proceed to shutting Diablo Canyon. Okay? Thank you.
Okay. I'm actually a late blooming activist. I've only been involved in this a few years, but I'm a quick study, and since San Onofre shut down, I've been studying the waste. I don't know how many of you are aware. The NRC made a decision last year that we can just leave the waste right where it is, basically indefinitely. And they recognized that we're not having a permanent repository anytime soon, and it's been impossible to find an interim site. What I have learned from listening to NRC technical meetings where you actually get the truth is the canisters that the fuel is currently being stored in at all our nuclear plants is subject to stress corrosion cracking, and they can fail within 20 to 30 years, have through-wall cracks. And they have no way to repair, They have no plan to deal with replacing them. This canister up here, they're planning to use at San Onofre. That green thing is about a 5/8 inch thick stainless steel, and there's a big concrete mass around it, and Diablo has a big concrete mass around it. What they don't tell you is there's air vents in that concrete to let to cool the hot fuel in the canister. So that big concrete is not doing you any good. But it makes a nice way to get the radiation out once that thing cracks all the way through. So that's what we're living with. In Edison, down at San Onofre, they want to spend even though they know this now, they want to spend $1.3 billion to put in another system that's even worse. And I'm intervening in the proceeding at the PUC to try and stop them from getting that money. Go to the next. Okay. Now, at Diablo Canyon, and I found this out on my own by research. They checked. They don't have any technology to inspect for cracks. It does not exist. Not when you have spent nuclear fuel in there. But they see down at the bottom left. That's a Diablo Canyon CASKS. It's got cement around it, and inside that vent hole is the thin canister. And they put something in there, and they took the temperature in certain spots, and they scraped it to see if there was any salt on there, because salt is highly corrosive to stainless steel. And they found the perfect conditions to create stress corrosion cracks, to start the cracking process. And even Dr. Singh, who is the manufacturer of the Holtec canisters, he says these are not really repairable, and with even a microscopic crack, you will have millions of curies of radiation being released from that one canister. Let's go to the next one. Okay. The industry will tell you we're not aware of any problems. That's probably a true statement, because they can't inspect them to see if there are a problem. So I have a handout, a couple of handouts in the back. One of them talks to you about the nuclear myths. This is on countering their BS they're giving everybody. So this is very excellent one to read. And then this is about some better solutions. So hopefully you get the handout. If not, you can go to my website and get those. They do not have any way to monitor that anything's going to start cracking. We won't know until after it leaks. Okay. Now there's a Coburg tank in Cape Town, South Africa. It's in the same environment as our West Coast plants, Diablo, Humboldt, San Onofre. We have salt, we have high moisture, we have onshore winds, we have regular fog. Those are the perfect conditions to trigger the cracking and have the crack go all the way through the container. That canister failed in 17 years. 17 years is all it took. And it was even thicker than the canisters at Diablo. There's an organization called EPRI, a nuclear industry organization, Electric Power Research Institute, and they cherry-pick data in the report that PG&E and Edison is using to say that it'll be 80 years before anything happens. They excluded this plant from the report. They excluded the variables of onshore winds, surf, fog. I mean, it's just a fraud, okay? And the only way you can find cracks, the only way you can really find them is to put some kind of dye inside the container, and that doesn't work with spent fuel canisters. But the nuclear industry is promising in 5 years, the industry will have it figured out. Don't worry, Donna, you worry too much. Okay. This is an actual quote from Dr. Chris Singh from Holtec. We managed to get him on video saying this.
Well, in my personal belief, it's not practical to repair a canister if it were damaged. If it had a through wall, then first we prevent it. But in the most unlikely circumstance, if that canister were to develop a leak, let's be realistic. You have to find it, that crack where it might be, and then find a means to repair it. You will have, in the face of millions of curies of radioactivity that is coming out of the canister, we think it's not the path forward.
You can actually hear the manufacturer saying this, and it took a lot of work to make that happen, but it worked. And they have no plan to replace. If you have a canister that's cracking and you need to replace it, you have to put it back in the pools of water inside the canister. The NRC allows decommissioned plants to destroy those pools of water, and they have no backup plan for what to do. Yeah, Rancho Seco no longer has pools. Humboldt Bay no longer has pools. Okay. And the Edison has tried different types of myths about how they can recover, and I've gone through and I'm busting their myths one by one. So right now they have no answer. And let's see. And the NRC was going to allow up to 75% crack in these canisters and say that's okay. And so I've been asking them, well, what's the seismic rating of a crack canister? You know. For some reason, they haven't been able to answer that question. I've actually filed comments on, I've been trying to stop the San Onofre system from getting approved. And so far, I've filed these comments. Diane Curran, the attorney that Friends of Mothers for Peace uses, she gave me some tips on how to work this NRC. And so using her advice, I submitted comments, and I've been able to, they've actually pulled from approval 3 canister versions so far. So I've had some success in getting delays at the federal level. So there's no early warning. The approved plant, the only way they can check for radiation monitoring is an employee walks around with a monitor on a stick every quarterly to see if the radiation's coming out. That's the current requirement. And you know, PG&E in one session I attended said, oh, we inspect our dry cask system. Employees check that every day. It's just a lie, but most people wouldn't know it's a lie because they don't have the details about that there's no technology to inspect canisters. So I've been able to, you know, catch them on their lies. And what needs to happen is we need the facts to get to the decision makers, and that's not happening. So I'm hoping by educating you, we can share the truth. Everything on my website is backed up with a government or scientific document, so and I try and use their own data against them. So, you know, I've got hard facts that we can take, whether it's to the governor's office or elected official or whoever, that you can use to, you know, prove that they've been lied to, because that's really what's been going on. And we successfully use this technique to shut down Diablo Canyon. I mean, I live in Orange County, and if I can turn these Republicans, the city council people, to have them say, this isn't what Edison told me, and say, why should I believe you? You've been lying to me. I've been able to turn Republicans on this issue. So if I can do that, I think, you know, we should be able to make some progress in LA County. Okay, I've done research on the market. We're using the thin type at the top. The Germans use a thick ductile cast iron, it's almost 20 inches thick. The French have a steel system that's 10 inches thick. It would be better. They won't crack. You can repair them, inspect them. They have early warning. They have ASME certification is American standard, American manufacturing standards. Our canisters don't even meet American standards. The NRC gives them exemptions from the standards. And Ralph Nader told me, American standards are bad. Those are low standards, and they can't even meet those. You know, no defense in depth. The Germans and at Fukushima, they put their thick cast in concrete buildings for additional environmental protection. So you don't need that big concrete thing for gamma and neutron protection with the thick cast. They come already built in. These will be a lot easier to transport. You know, it's all in one. With the thin cast, you have to add, you have to transfer it between the pool and the dry cast with a transport cast. And if you want to transport the thin one, you have to put it in a thick steel transportation cast. Then you got to take it to another location that already has another concrete mausoleum built for it, so it's just a lot better. The problem, why can't we get the thick cast, you're wondering? Is anybody wondering? Okay. All right. Okay. Yeah. Okay. The NRC will only license something if they have if there's somebody that wants it. If there's somebody that wants this product, like a utility company, then the vendor will submit an application for a license to the NRC. It takes millions of dollars, and it's 18 to 30 months. And no vendor will apply for an NRC license unless they have a customer. And right now, we do not have a customer. So I'm trying to force Edison to be a customer. So if we can make this happen in Southern California and change the industry to better technology, I think it'll be kind of a seismic shift, pun intended, for the rest of the country, for Diablo, for the rest of them. So the fight's at San Onofre right now to change to safer technology. You know, maybe will buy us 100 years. You know, so far that's the best. So, so I'm running low. Yeah, and yeah, the NRC, they're totally captured by the industry. So they will lower their standards to meet whatever the current vendors offer. And the only thing the NRC is good for is buying some delays and using their information against them. Okay. This is how Germany stores theirs. They put them in buildings, clean. You've seen the pictures of WIP, right, where it's all a bunch of junk stacked together in thin canisters. So the recommendations are basically we need to stop them from buying any more of these canisters. We need to have the Public Utility Commission, the California Energy Commission, mandate minimum requirements. If you're going to store waste in California, we're the users, we're paying for them. We should be able to set requirements. Even though the NRC approves the systems, we can have requirements. The Public Utility Commission approves the funds, so I'm in that battle right now. I made some progress with Commissioner Florio and with the judge. I said these canisters are going to fail in possibly 20 years, and we're going to have to come up with another $1.3 billion that we don't have to replace them. And Edison objected, and Florio says to Edison, "You mean to tell me it's not PUC jurisdiction if we have to spend another $1.3 billion for this system?" So I mean, I kind of felt I had him on his side, and then I told the judge that Edison didn't even get bids from the thick cast companies. They only got bids from the thin ones. And so we don't even know how much they will cost. And you know, they could cost more, they could cost less. And the judge lit up and she says, "You mean we might be able to save money if we got more bids?" I said, "Yeah, we might." So, I mean, I seem to hit some buttons with the PUC, okay? You can reach me through my website. You could really use more people involved in this effort. I mean, one canister holds more radiation than all the atomic bombs that have ever been set off in the world. Just one.
This is Donna's final slide here on the dry casks. And it shows that we really have a short deadline to deal with this stuff. Rancho Seco, of course, is shut. San Onofre is shut. Humboldt Bay is shut. And hopefully Diablo Canyon will soon be shut.
How many years before the canisters will probably crack open?
You can tell Donna is amazingly hard working with us. Fantastic.
Yeah, it's not an egg.
Donna Gilmore. All right, I'll try to make this as quick and painless as I can, but I have some news that could actually destroy California if we don't do something this year. All right, did I get people's attention? Okay. What I learned is about the waste that's stored in San Onofre, Diablo Canyon, Humboldt, and Rancho Seco, New Sacramento. Those canisters that they're storing the waste in, one canister holds more waste than Chernobyl. One canister. And I have data to prove that it will fail, likely fail in 8 years. What's Southern California Edison doing? They're going to spend over $1 billion to buy more of these thin canisters. I call that premeditated, I don't want to say murder. California, really. I mean, it's crazy. They're incompetent. I helped shut down San Onofre. Now I'm working on this. I took on Edison at the Coastal Commission this week, stopped them from getting approval from the Coastal Commission to put in this new system that's even worse than what they have. I'm intervening in the Public Utility Commission, and I've stopped them from getting the money to buy more of these inferior canisters. But I need your help to educate, to network, to bust the myths of what Edison has been telling the governor and the elected officials and the regulators. I think Commissioner Florio wants to do the right thing at the PUC, and he wants to stop Edison from buying these. And but I need your help to use your networking and whatever challenge you have to put forth. We, for San Onofre, we would go to city councils, we educate city councils, and we would, I have a website, sanonofresafety.org, where I put indisputable facts about the issues. And I've been able to bust Edison lies one after another. I use facts from the Nuclear Regulatory Commission, from the PUC, I use hard data, and we were able to shut San Onofre. And we can stop this. And California needs to be the leader and switch from these thin, half-inch thick canisters that are subject to cracking from our marine environment. We need to switch to thick CASKS technology, up to 20 inches thick versus half-inch thick, that's used in Germany and other places. And Edison right now refuses to do it. So we have to force it. And that's the only other option. I don't like to come with problems without solutions. And the only solution that there is in the world is a thick canister technology. I mean, we all want the waste out of here, but I studied this and I found out there's no way we're going to be able to push this waste on any community or military base or anything in any time frame before these will crack open. And one of these cracks open, it will, according to the vendor of the canister maker, it will release millions of curies of radiation into the environment. We need the best technology in the world, and it will not happen without California and without the Democrats getting on board and putting, getting this information out there. So I urge you to please help me in this battle. We have to win this battle this year. Okay? Thank you.
I'm really honored to be at the table with these three folks because, we have in our 90 or so person division here, and really we have in the business line 110 or so FTE, full-time equivalent folks, that many of those are experts within their respective areas of review that they do for us, whether it be thermal containment or criticality. But these three folks, I tell you, they have such a great background and they've learned so much. I don't think any of them are engineers, but they know a lot about our business, and they've really done a great job to educate themselves, and they're movers and shakers within their respective areas of that they work in. So I want to say thank you all three for coming. It's important to us. It's important to us as an agency. It's important to me as leading this business area within the NRC, that we not only communicate of who we are and what we do, why we do it, how we do it, but we really listen to folks like yourselves and listen to your perspectives, because you have so much to offer us. it can be a situation where we're stuck as engineers into thinking certain ways, and you help us to think outside the box in many different ways. So please continue. And I know Donna's very good at this. Continue to challenge us, but keep doing so, because it is important to us to think more on our position. So our first speaker is Donna Gilmore. She's the founder of San Onofre Safety. You can find them at sanonofresafety.org. It's an organization that provides factual government and scientific information on the serious safety issues found at the San Onofre Nuclear Generating Station in San Clemente, California. Since the closure of the reactors at SONGS, San Onofre Nuclear Generating Station, the focus of the organization has turned from operational safety issues to issues of nuclear dry cask storage. Their website, which I just gave you, sanonofresafety.org, is used around the world by journalists, engineers, elected officials, and the general public for credible sourced information on nuclear safety issues. Recent publications by Donna include High Burn-Up Nuclear Fuel, Pushing the Safety Envelope in January 2014, which was co-authored with nuclear physicist Dr. Marvin Resnikoff, who we talked with several times as well here. Diablo Canyon, Conditions for Stress Corrosion Cracking in 2 years, October 23rd, 2014, and San Onofre Dry Cask Storage Issues, September 23rd, 2014. She has over 30 years of experience in information technology project management, including the design and implementation of major technology systems for the state of California and the management of a large engineering data center. So please welcome Donna.
I've gotten interested in this when I heard San Onofre was firing employees for reporting safety problems, and I decided to look into this. And we don't have time to go into all that background, but I haven't been doing this very long, but I've been finding information that I'm very concerned about, and I feel these issues need to be resolved sooner rather than later. The game changer here is this indefinite storage decision on site. It's time to step back and look at things in a whole nother way than the way it's currently being done, okay? In researching the current thin canisters that we use, these are the welded steel ones, I learned from attending the Darrell Dunn NRC presentation that there's no current technology that can inspect or repair adequately these canisters, and the NRC is giving them 5 years to come up with a way to inspect them for cracking and corrosion and other things. But there's no solution for preparing canisters that have spent fuel in them. There's other technology for stainless steel repairs, but not in dry storage canisters. And there is no early warning system. We have somebody that walks around periodically and checks the canisters to see if they're leaking radiation. So I'm very concerned. And the urgency here is Edison, Southern California Edison, that manages the plant, plans to spend $400 million, anytime soon, as soon as I suppose they can get some approval, for about 100 canisters of the thin, what I call the thin canister type, which I don't think will hold up for long storage. So NRC is planning to revise their new Reg 1927 to deal with aging issues, but not until spring 2015. So if you could slow down Edison to not buy anything until we get that done, that would be great, Mark. So anything you can do there, okay? The NRC's aging management plan, let me know, Mark, if this has changed from the technical sessions I attended. The first inspection will be after the canister's 25 years old. 5 of those years are to give the industry time to develop a way to inspect those thin canisters while they're sitting inside the thick overpacks. They're only requiring the inspection of one canister, and we're just talking about the outside of the canister, just one canister at the plant. And then that same canister would be inspected every 5 years. Okay, and then this was interesting. They plan to allow up to a 75% through-wall crack of that canister. And my question that has been unanswered is, I know that when you do seismic evaluations, they're done on intact materials. So now we have a canister that could be cracked up to 75%. In their technical specifications, I'm not aware that there's any seismic evaluation of that condition. So. Now, in January, a 2-year-old Diablo Canyon canister showed conditions for cracking. The temperature was low enough for the humidity and salt to, coalesce, or whatever the proper word is.
Deliquesce.
melt or dissolve, whatever, on the canister. And that was only 2 years, okay? So that means you have conditions for corrosion which can lead to crack initiation potentially in a 2-year time period. If I have some of my interpretations incorrect, please let me know. I took a look at what else is out there on the market, and the only other thing I see are these thick casks. One is the Arriva TN series, which they're about, 8 or 9 inches thick, forged steel, and then there's the ductile cast iron technology. Well, they're all bolted up to 20 inches thick. And the thick what I refer to as the thick canisters, they are not subject to the cracking as the thin ones are. You can repair them. Well, 20 inches thick, I don't think you have to worry about the monolithic ductile cast iron having problems, but you can replace seals, so there's some repairableness there. You have the ability to inspect the outside because you don't need that extra concrete that protects from the gamma and neutrons. The thick canister does the full protection for radiation. No early warning monitoring system. The bolted canisters have a pressure. There's pressure in the lid, and a change indicates there may be like a helium leak, so you may have to change the seal or something. ASME certification. The casks themselves, the thin canisters, the thin ones, the canisters themselves do not have ASME certification for storage or transportation. Maybe the facility might, but the canister doesn't. The thicker canisters have ASME certification and international certifications for storage and transport. And the dispense in depth, we'll talk about it later, but that's also an issue. This is a picture of a CASKS V19 as an example. They use an epoxy on the outside. And I'm not going to go through the whole list. These slides are available. I put more detail in the slides than I plan to cover so that you don't need to hear me talking to understand the slides. I did need to make one point. The thick German canister is not currently licensed in the United States. None of the utilities would buy a canister that cost more money. So because they couldn't get business in the United States, they didn't apply for a license. The licensing process is, according to Mark, is 18 to 30 months. It means a lot of money for a vendor. They wouldn't have priority because they didn't have a customer. So it's pointless for a vendor to get a license unless they have a customer. So any of you that are utilities, if you want to consider the other technology, I've convinced the German company to talk to you and, maybe bid. So if you're interested in something that's designed for more longer-term storage. Okay. All right. There's been this myth that the thick ductile cast iron canisters are subject to cracking or being brittle. There's a Sandia Lab study that states they actually perform in an exemplary manner. They actually exceed a number of NRC requirements. You can look at that later. Let's move on. Most of other countries, they use the thick casts. They put them in buildings. We leave them out exposed. So this gives you additional protection from environment and other external factors. That's just a picture. You can see what they look like. Now, overall, I think I've already pretty much gone into most of these, so we'll just skip that one. Okay, and I've said there's no seismic rating, no repair. There's more details on these slides to back up the reasons I'm saying this, but let's go on. They're not designed to be replaced, as Mr. Boyle said. That's why they're using the bolted canisters in their tests. They were never intended to be replaced, but now we're stuck with these things, and we're probably going to have to replace them in 30 years, 40 years, whatever the time frame is. So that's a problem. And in the canisters, whether you're talking bolted or welded, if there's a failure where the canister needs to be unloaded, right now the only way you can do that is if you have a pool. Well, the NRC allows nuclear plants, after they've unloaded the fuel out of the pool for decommissioning, they allow them to destroy the pool. So they've destroyed the only way we have to replace a canister if there's a problem, from aging or whatever. Right now in California, we have Rancho Seco, Humboldt Bay. They have canisters. They don't have a pool. If anything goes wrong there, what happens, Mark? What happens if something goes wrong and those things crack open and there's no pool? What's going to happen?
Well, initially, we actually, through the aging management program, we detect any cracking ahead of time.
You don't have any technology to detect cracks.
Well, there are technologies that can be used to detect cracks.
Not in spent fuel canisters.
They are, there was I think
That's
Bill
why
Boyle.
you've given them 5 years to come up with something.
Okay.
Okay, so, okay.
There is a response to that, but we don't have enough time to go through the
all
details.
Right. Okay. On the defense in depth issue, as was said earlier, I think by one of the EPRI speakers and other speakers, the defense in depth, the first line is the thin canister, 1/2 inch, 5/8 inch canister. The second line is the zirconium-clad fuel. So if that fuel is not intact, you have damaged fuel assemblies, and you put it in a can, you're not getting that back because you've got vent holes on the ends of that can. In the German canister, they seal their damaged fuel, either the rod level or the fuel assembly level, depending on the damage, in totally sealed cans. So you do have a replacement for that defense in depth. Okay, and recommendations. We need you to do something now before Edison spends all that money, okay? Somehow, directly, indirectly, freeze procurement of that till we can get this settled. Set higher storage standards. Now we have this extended storage requirement. We need you to take the leadership role to raise the standards. Don't worry about what we have now, what everybody owns. We have to think in terms of what we need. What's in your hand is the future of California, the future of everybody else's state. So this is not the time to, how did I put it, play bureaucratic roulette with the future of the United States here, or of California. We need to step back from all the, bureaucratic thing and really look with fresh eyes that we have a whole different problem here. And your standards needs to be raised, not lowered based on the limitations of the thin canister design. Take a look internationally, what's out on the market, evaluate them, based on what I've read and people I've talked to, engineers, physicists, it appears to be a better technology that might buy us quite a few more years, okay? And then to the utilities, please take this serious. Please step out of the box. The prices have changed. The price of metals has changed. The German design may be much more competitively priced, but we won't know until we can find a customer that will seriously allow them to bid. If you go to San Onofre safety.org or you get a copy of these slides, all the things that I have on these links are documents with 10 zillion more resources from NRC, government documents, EPRI documents, labs, backing up everything I have in this presentation. Okay, there's this myth about the Fukushima canisters held up, therefore ours will hold up. Well, they used the thick bolted lid canisters at Fukushima. They did not have high burnup fuel. This is a picture of where the Fukushima CASKS were stored. This is a before picture, not an after picture. So they were housed in this facility, totally different than what we have. So anybody that says, the CASKS held up in Fukushima, therefore we're okay, totally different, oranges and apples. This is a picture, a graph I got out of, I forget which technical document, but you can see from this, when you start going into high burnup fuel, you start having more cladding failures. You get up in the mid-30s, you can see the trend, it kind of shoots up and you get more oxide thickness on there, which is an indication of a problem. Now, I think Bob will probably at some point want to make a comment on this, or maybe you and I can
Make it right now?
not no. Let's say what I'd like to do is talk to you offline, and then we and deal with that. But this is an indication of something, and maybe Bob, you and I can talk afterwards, and we can come to some center on this. This is just a slide that was that Daryl had presented at one of his meetings, talking about the conditions needed for cracking, and that there were other types of components that had cracking within 11 to 33 years where the item had to be taken out of service. Just go on. These are actual examples where they had through-wall cracking of other components. You can look at that later. That's just a picture of all the things we don't know. This is a DOE slide showing just areas of things that we do not know about dye canisters. So saying that we have all this confidence, I kind of wonder. It's San Onofre. This is the kind of cesium we've got. To the left, you see how much cesium there is in a 10 megaton weapon. The last 3 bars on the right are the cesium that we have at San Onofre. So our concern in Southern California is we want to have the best, we deserve the best on the market to protect us as best as possible. Maybe Bob will think it's overkill, but what's the future of California worth? And the wind blows east. You're talking about our food supply. You're talking about we have 40% of the import-export cargoes for the whole country. You're talking about devastation of California. You're talking about devastation of the national economy, which is going to affect the initial economy. You know, what kind of price are you going to put on that? Okay, this is our unique problem at San Onofre. You other nuclear plants are doing a much better job here. This is a slide of plants that are currently in decommissioning status. And this slide represents the number of safety complaints from employees to the NRC regarding problems at San Onofre. You can see we're a special case here compared to the rest of you. The rest of you are doing a much better job. Okay, I attended a session where they talked about approving M5 for St. Lucie Unit 2. M5 is a new improved, quote unquote, zirconium cladding. This slide shows in storage that both the new improved Zerlo and M5 have more problems than the Zircalo 4 they were using before. And when I brought this up in that NRC meeting, they said, well, it works better in the reactor, and the fuel issue is like somebody else's issue. So this idea that you can approve fuel in the reactor and only look at how it works there without looking at what happens when you flush it down the toilet and give it to us in dry storage. To me, those things should be together. You shouldn't be approving new fuels until you know how it operates in storage. This is what is causing all this problems we have. Okay, but that's it. That's all I've got.
The time to make the break is now, to wind and wave and solar power. If we're gonna live, nuclear power must be banned. Wrap your mind round Fukushima. It's no time to be a dreamer. Google Fukushima, take a stand.